Alright, we're on number 6, lesson number 6, talking about tolerance today, and your learning target is I can choose an appropriate level of accuracy when reporting measurements. Let's get going on tolerance. So the first thing we need to do is identify or answer the question, what is tolerance? Okay, and tolerance is the amount that a measurement is okay to be off by. Okay, so let's give an example of this. Let's talk about baseball for a second. In baseball, what baseball recommends for major league fields is that the wall to the home plate should be around 360 feet plus or minus 40 feet. And that's the entire distance around from foul line to foul line. It should be somewhere in between these measurements. It doesn't say specifically how far it has to be, but it says that minimum it needs to be somewhere, the recommendation is somewhere between 360 feet plus or minus 40 feet. Okay, and that's how we write it. That's how we write a tolerance, is that it's supposed to be 360 feet plus or minus 40 feet, and that's how we read it as well. So let's do an example of that, and I hope the example make a little bit more sense. So we've got this company in example 1 that's called Acme Nuts and Bolts, and what they do is they manufacture bolts to use in an airplane. The length of the bolt should be 50 millimeters with a tolerance of 0.5 millimeters. Alright, a batch of those bolts have the lengths shown in the table. Do all the bolts measure within the specified tolerance? If not, which bolts are not given within the specified tolerance? So first of all, let's take a look here. We know that it should be 50 millimeters. Okay, and if we were to write this the way that it's normally written, that'd be plus or minus a tolerance of 0.5 millimeters. So this is, we're looking for a distance somewhere in between here. Okay, so to figure out what that should look like is we have to first add 50 or 0.5 to 50, and then we have to subtract 0.5 from 50 to kind of get our range of what we're looking for. Okay, so let's first go ahead and add 50 plus 0.5, and we end up getting, that one's pretty easy to add. It'll be 50.5 millimeters. If you need to, you can use your calculator on that. And then we also need to subtract it. And we see then we get 49.5 millimeters as our low end. Okay, so what we're looking for is this bolt. Let's just identify the bolt as B. This bolt needs to be between 49.5, needs to be greater than that, but less than 50.5 millimeters. Okay, so let's go ahead and let's look at these measurements here and decide which ones are in between that range and which ones are not. 49.8, that's greater than 49.5, but that's less than 50.5. So this one is a yes, that one works. 50.4, that looks like that's in between the two as well. 49.5 is right on the borderline, but that is true. That is, it is in between those, and actually we should put in equal to. It can be equal to as well. D is 50.1. That is right on the line as well, so that works. 49.4. 49.4 is less than 49.5. So bolt E here is a no. That does not work. And 50 is right on the mark. That's exactly where we wanted it to be. So that one is a yes as well. So if we go through and we answer the question, it says, do all the bolts measure within the specified tolerance? Well, all but one. And if not, which bolts are not within the specified tolerance? And so therefore we have to say that bolt E is not in the specified tolerance because 49.4 millimeters is less than 49.5 millimeters. Okay, and that's how we go about solving one of those types of problems. All right, example 2 adds a little step into this, into these problems. It says to write the possible range of each measurement around to the nearest hundredth if necessary. Okay, so we're going to do A first, and A says that we have 50 kilograms. That's what it's supposed to be at. That's what every measurement's supposed to be, with a plus or minus of 2%. Okay, it doesn't give us an exact measurement. We have to figure out what that measurement is. And to do that, what we first have to do is we have to find out, well, what is 2% of 50? So we have to multiply 50 times 2%. Okay, and anytime we're multiplying by a percentage, really all we are doing is we're moving the decimal point over twice to get rid of the decimal. And so that would be multiplying by 0.02. If we move the decimal point back twice, it'd be 0.02. And if we do that, we can get our calculator here and do 50 times 0.02, and we get 1, okay? So that means then that we're looking at 50 kilograms plus or minus 1 kilogram. 1 kilogram is the specified tolerance that we're able to vary by. Okay, and so this would be the right answer. What we're talking about then is 49 kilograms, because 50 minus 1 is 49, is less than x, which is less than 51 kilograms. X being that possible range that we could be in. All right, now B is the same type of deal here. We've got 125 pounds plus or minus 1.5%. So we have to first multiply 125 times 1.5. 125 times 1.5%. Again, remember that just means that we're moving the decimal point over here twice to get rid of the percent sign. So we're multiplying by 0.015. Okay. Again, I don't know what that is. I don't know 1.5% of 125. So let's go ahead and use our friend here. Say, hi friend. 125 times 0.015 is 1.875. 1.875. Okay, so then if I'm writing this as for what our range is, we're going to take 125 pounds and we're going to add or subtract to that 1.875. But remember, we're supposed to round to the nearest hundredth. Hundredth is this point right here. The 5 rounds the 7 up to 8. So really this is 1.88 pounds. Okay, so let's get our range then, and our range again is going to be 125 pounds minus 1.88 pounds. So let's go ahead and do that. We're going to do 125 minus 1.88. 125 minus 1.88 is 123.12. 123.12 pounds is less than X. That's the range that we want to be in, which is less than 125 plus 1.88. Well, that's kind of easy to do. 126.88 pounds. That means that we're supposed to be within this specified range. All right, that's all we're doing for tolerance here, and I hope you enjoyed it.